Okay, so in this video here, we're going to be talking about how to solve nonlinear systems, and in particular when we're dealing with a circle and a parabola. So in order to do this video here, you have to know how to solve a linear system of equations. So if you do not know how to solve a linear system of equations, make sure you check my videos below. I'll go ahead and link them. I have videos on how to do that. But assuming you know how to solve a linear system of equations, let's go ahead and talk about how we're going to solve this nonlinear system of equations. Now, the first thing you have to understand, we're dealing with a circle and parabola, so we could have multiple solutions here. So for example, if you draw a circle and then you put a parabola on that circle, you could have something like this here where it's intersecting at exactly one point, right? So this intersection point right here, that would be considered one solution, right? Or you could have another circle, right? And if you put on a parabola, it could be passing through at two spots, right? Meaning it's going to have two solutions being right here and here. So that's a possibility. Or you could have three, right? If you have a circle and then you have something like this here where the parabola is going all the way down and intersecting at that one point and then coming back up, right? That would be 1, 2, and 3 solutions, right? So we're going to put 3 here. And then you could have 4. So again, if you have a circle and you put on your parabola, you could have something like this here where you have 4 solutions, 1, 2, 3, 4. So those are all your possibilities. Now, you don't have to know that going into solving these. You don't have to know how many solutions it's going to have because your answer is going to dictate that. But just so you're aware, there is a possibility that you could end up with more than one solution, and typically you will, right? So let's go ahead and get rid of all this here, and we'll talk about how we're going to do this problem. Now, you can do this problem by using elimination or substitution, just like you would when you're solving a linear system of equations. But this one here, I'm going to use substitution. And in particular, if I look at equation 2, so for example, equation 2 is right here. This will be equation 1. If I isolate x squared, I can then plug that into my x squared up here, okay, on equation 1. And to isolate x squared, all I have to do is multiply all of my terms by a negative 2. That will get rid of this negative half right here, and then I'll have x squared isolated. So for example, if I multiply all of my terms here by negative 2, I get negative 2y, and then I get plus 12 equal to x squared. Again, I'm just multiplying all of my terms by negative 2. I'm manipulating the equation, but I'm not actually changing it, right? And so now that I have x squared isolated, I can go ahead and plug it into equation 1 wherever I see x squared. So for example, I have an x squared right here. I'm going to plug in negative 2y plus 12. So let me go ahead and do that. I'm going to put negative 2y plus 12 and then plus y squared equal to 36, right? So just plugging it into equation 1. And from here, I can see that I have a quadratic, and we solve quadratics by factoring or using the quadratic formula. Technically, you could complete the square, but typically, I always use factoring or quadratic formula. But before we do that, we have to set it equal to 0. So I have to take this positive 36 and I have to move it over to the left-hand side. So I have to minus 36 on both sides, right? Okay. So when I do that, this will cancel out over here. I'm going to go from highest degree to lowest degree. So I get y squared, and then I get negative 2y. And then 12 minus 36, I get negative 24, all equal to 0. So from here, I'm going to try to factor the quadratic by using the AC method. And if you don't know how to do the AC method for factoring, again, I have videos on that as well. So I'll link them below. That way you have access to that content. But doing the AC method here, I do a times c. Now my a is 1. That's that coefficient in front of y squared. And then c is going to be negative 24. So when I multiply them, I get negative 24. So I need two numbers when I multiply that will give me negative 24, but add up to my b, which is negative 2. Well, that's going to be negative 6 and positive 4. When I multiply them, I get negative 24. And then when I add them, I get negative 2. And since a is equal to 1, I can put it right in factored form. I get y minus 6 and then y plus 4 all equal to 0. Solving each one of those factors, I get y is equal to positive 6, and then I get y is equal to negative 4. Okay, so we have some y values now. Now we want to plug it back in to get the x values. Now it doesn't matter what equation you use here. I'll just go ahead and use the second equation right here. So for example, I can use this equation right here that we manipulated. That's fine. And then I can solve for x. You could plug it into equation 1. It doesn't matter. But I'll just go ahead and use this equation right here. That's fine. So I'm going to go ahead and scroll down. That way we have room. And I'm going to rewrite that equation. That way we know what it is. It's going to be negative 2y plus 12 equal to x squared. Okay, so there it is. So wherever I see a y, I'm going to plug in a 6, and then I'll do it again, but I'll plug in a negative 4. So why don't we go ahead and do 6 first and then go from there? So plugging in a 6, we get negative 2 times 6 plus 12 equal to x squared. Okay, this will give me negative 12 plus 12 equal to x squared, or in other words, 0 is equal to x squared, which we know is going to be 0 is equal to x, right? Taking the square root on both sides. So that's a point. I plugged in a positive 6 into y, and I returned a 0 on the x. So I'm going to start listing out these points because that is going to be part of our solution. So we're going to go ahead and scroll up here. And in red, I'm going to go ahead and list out what we just got. So I plugged in a 6 in the y, and I returned a 0 on the x. So for example, that is going to be 0, comma 6. Okay? There's 1 point. So there's part of my solution. We now have to do it again for the other y value. In this case here, negative 4. Okay? So scrolling down, now we're going to use negative 4. Okay, so why don't we go ahead and section this off. So now I'm going to plug in a negative 4. So I get negative 2 times a negative 4, right, plus 12 equal to x squared. We know that negative 2 times negative 4 is positive 8. And plus 12 equal to x squared, or in other words, 20 is equal to x squared. And then from here, taking the square root on both sides, we get x is equal to plus or minus square root of 20. Now you can leave it as the square root of 20, that's fine, or you could go ahead and use prime factorization and break that down. So for example, over here, if we do the square root of 20, two numbers when I multiply that will give me 20 will be 4 and 5. Okay, 5 is prime. I can keep going with 4. I get 2 and 2. I have a pair of 2's, and since I'm dealing with a square root, I can pull out those 2's. It becomes just 2, and I'm left with 2 square root of 5. So I could actually write here plus or minus 2 square root of 5 if I wanted to, and I will, okay? So that's actually 2 points. We plugged in a negative 4, and I returned plus or minus 2 square root of 5. So I'm going to go ahead and scroll up here, and I'm going to list out those last 2 points, and then we'll be done. So again, I plugged in a negative 4 into y, right? And I returned plus or minus 2 square root of 5. So my first point is going to be 2 square root of 5, comma negative 4. And then my second point is going to be negative 2 square root of 5, comma negative 4. Okay? And so now this is going to be done. All right? Here's my solution. I can clearly tell that this circle and this parabola, they are intersecting at 3 different points. And there it is. Okay? So let's go ahead and try one more example. Okay, so here's our next problem. And I'm going to go ahead and label my equations as equation 1 and then equation 2. And so what I'm going to do in this problem here, I'm going to solve for equation 2. I'm going to solve for y squared. Once I do that, I'll plug it into equation 1 right here, and we'll go from there. Now, to do that, I'm going to have to get rid of this coefficient of 2 right here, meaning I'm going to have to divide all of my terms by 2. So the new equation that will result if I do that will be the following. So I'll get x over 2 minus 3 over 2 equal to y squared. I can then plug this into equation 1. So rewriting equation 1, I get x squared plus x over 2 minus 3 over 2 equal to 9. So again, I plugged in y squared, where I saw a y squared. That's this part right here. And so from here, you can see that you're dealing with fractions here. So if I simply just multiply all of my terms by 2, I'll get rid of this fraction here and this fraction here. So that's what I'm going to do to make it a little bit easier. So rewriting it, I get 2x squared plus x minus 3 equal to 18. Okay, multiplying everything by 2. From here, I can see that I'm dealing with a quadratic. So to solve quadratics, we set them equal to 0, and then we solve. So I'm going to go ahead and take this positive 18 and move it over to the left-hand side. To do that, I minus 18 on both sides, right? This will cancel out, and then I get the following. I get 2x squared plus x minus 21 equal to 0. Okay? So I'm going to try to factor this using the AC method. So using A times C, and again, I can't pull out a greatest common factor here, but I can still try to factor it using the AC method. So doing A times C, 2 times a negative 21 will give me negative 42. So I need two numbers when I multiply, that will give me negative 42, but add up to my B, which is going to be positive 1 right here, right? A positive 1 in front of that x. So the two numbers that I can use here are going to be 7 and 6, and then one of them has to be negative, and that's going to be the 6. The 6 has to be negative. When I multiply them, I get negative 42, and then when I add, I get the positive 1 right here, right? And so from here, since A is not equal to 1, okay, I can't put it right in factored form. So we actually have to do factoring by grouping, and I'm assuming you know how to do that. But again, if you don't know how to do that, I have videos below linked. That way you have access to that content, so go ahead and check them out. But assuming you know how to factor by grouping, we're going to go right for it. So I'm going to rewrite the problem as 2x squared, and then I'm going to grab one of my values. It doesn't matter. I'll grab the negative 6. So negative 6, and then put x, and then positive 7, x, and then minus 21 equal to 0. So remember, when you are factoring by grouping, you're essentially rewriting your bx term right here, which is negative 6x plus 7x, that is positive x. But when you factor by grouping, you should have 4 terms when it's all said and done, and I do. So I group together the first 2 terms, and then I group together the last 2 terms, and then I go from there. So the first 2 terms, I can pull out a 2 and also an x, okay? That will leave me with x minus 3. And then my last 2 terms, I can go ahead and pull out a 7, so plus 7, and that will leave me with x minus 3, again, inside, equal to 0. So when you factor by grouping, this is your confirmation right here, your common factor. I have x minus 3 and x minus 3. So if you did it correctly, you should have a common factor. I do. Now I can finally put it in factored form. So for example, it's going to look the following way. Scrolling down, we write the common factor one time, x minus 3. And then we write the outside values together, 2x plus 7 as a factor. So for example, 2x plus 7 equal to 0. Now we can solve our factors. We're almost there. We get x is equal to 3, solving that first factor. And then solving the second factor, I get x is equal to negative 7 all over 2, okay? So you could have solved that using the quadratic formula. If you don't want to factor by grouping, you don't have to do it this way. Just plug it into the quadratic formula and you're going to get the same thing. But now I can see that x is 3 and x is equal to negative 7 over 2. So now we're going to take these values and plug them back into the original equations and see what we get for y. So I'm going to start with 3. I'm going to do this one first, and I'm going to plug it into equation 1. So if we scroll up, equation 1's pretty easy. I'll go ahead and plug it into that one and see what we get. So I'm going to write equation 1 below. That way we have it. So it's x squared plus y squared equal to 9. So I'm going to plug in my x value here and see what we get for y. If I plug in x, that's going to be 3. So I get 3 squared, right, plus y squared equal to 9. Well, 3 squared is 9, and then plus y squared equal to 9. And so you can see what's going to happen here. I'm going to move the 9 over by subtraction, and I get y squared is equal to 0 because I get 9 minus 9. That means if I take the square root on both sides here, y is going to be equal to 0, okay? So that's a point, 3, comma 0. I'm going to go ahead and record that up top. That way we have that information. So going up top, we get the following. One of our points here is going to be 3, comma 0. All right. Now let's keep going. We have to do it now for negative 7 over 2, and we're going to plug it into that same equation. All right. So plugging in negative 7 over 2, we get the following. So in parentheses, negative 7 over 2, and then squared, right? Plugging it into x, plus y squared equal to 9. When I do this out, I get 49 over 4, right? Applying that exponent to both the numerator and denominator, and then plus y squared equal to 9. So you can see here that I'm dealing with a fraction, but we'll go ahead and move it over to the right-hand side. So doing that, you get y squared is equal to 9 minus 49 over 4. Again, we have to move that fraction over to the right-hand side. That way we can solve for y. From here, I'm going to go ahead and combine these, okay? That 9 is really over 1. So, for example, it's 9 over 1 minus 49 over 4. So essentially what you have to do here, you have to take this fraction here and multiply both the top and the bottom by 4. That way you can get a common denominator and you can combine them together. So if I do that, multiply by 4 here and 4 here, right, you get 36 over 4. So now you have y squared is equal to 36 minus 49 all over 4. Again, I'm writing it all as 1 now because they have the same common denominator of 4. Cleaning up your numerator, that's going to give you negative 13. All right, so let's go ahead and scroll down. So I get here y squared is equal to negative 13 all over 4. And then finally, I take the square root on both sides. I get y is equal to plus or minus. Now remember, when you apply the square root to a fraction, that happens on both the numerator and denominator. So technically, you're writing it like this: square root of negative 13 over square root of 4, okay? Well, we know that the square root of 4 is going to be 2. So I can go ahead and replace this part here with 2. But the square root of negative 13, that is not a perfect square. And also, it's going to lead to an imaginary number because I have a negative here underneath my square root. So I want to go ahead and pull out an I. All right, so finally, our final answer for y is going to be the following. I'm going to write it over here. Y is equal to plus or minus I, pulling out that negative, right? Square root of 13 all over 2. Okay, that's how we can write it. And so now we're pretty much done. So that's actually 2 points. I plugged in a negative 7 over 2 into x, and I returned this plus or minus square root of 13 over 2i. All right, so I'm going to go ahead and write it up top. Now, when you write your final answer, you can go ahead and put this I at the end. That's fine. I put it at the beginning here. It really doesn't matter. But when I write my final answer, I'll put it on the end. So scrolling up, we're going to get the following. Okay, I plugged in a negative 7 over 2 into x. And one of the y values that I got was positive, right, square root of 13 all over 2 and then I. Okay, that was one of them. And then the other one was the following. I plugged in a negative 7 over 2, okay, comma, and I returned a negative, right, square root of 13 all over 2, and then again, I, meaning it's imaginary, okay? So there we go. So I have one real solution here, and I have 2 imaginary solutions here. So what would happen here, if you were to graph both of these equations on a coordinate grid, you would see that it's only actually intersecting at 3, 0, because my other 2 solutions here are imaginary, right? And so they're not going to show up on the graph. So just keep that in mind. If you were to graph both of these equations, it is only going to be intersecting at 3, 0 right here. That's the only point of intersection you're going to see. But technically, I have 2 imaginary solutions here. So I'm going to go ahead and include them in my final answer. All right. So that is it. And if the video did in fact help you, if you could just go ahead and give it a thumbs up, that would be greatly appreciated. Also, make sure you subscribe. That way you get more math videos in the future. And I'll see you in the next one.